Good morning, everyone. Thank you very much for joining us this morning. It's almost a minute to 10, so we'll get ready here to get started. So today we'll have two talks. The first one will be on insect management, and then the second one will be on disease management in wheat. So thanks again for joining us. We'll have an opportunity to ask questions either at the end of each talk, but also after the hour. We'll have extended discussions for those who may want to stay on and continue the discussion. Just would like to remind you that at the end of each talk, we'll have a short poll. I would like to ask your input on how we can improve on the delivery of the information. We'll also be sending out an email at the end of the week with a questionnaire, a short questionnaire to ask you again how we can improve on delivering information to you. So today, again, thanks for joining us. We'll have two presentations. The first one will be on insect management. This will be given by our entomologist, Dr. Adam Varenhorst. Adam comes to us from Iowa, not far from South Dakota, actually the southeast corner of South Dakota. And he grew up on a farm that has a lot of experience having been raised on a farm, but also a lot of experience with insect management, stemming from the work he has done at South Dakota State, but also what he did at Iowa State University. So without taking much from him, over to you, Adam, on the talk on insect management. All right, so apologies for some technological challenges. So we can start with the disease management portion, and then Adam will come on later, if that's okay with folks. So I'll start then with the presentation on disease management in wheat. So I'll give a little bit of an introduction for those who may not know me. I grew up in Uganda and then moved to the US, started at Iowa State where I did my grad school, worked in Nebraska at the University of Nebraska on wheat for about 2 years, and then started here at SDSU about 7 years ago. So time goes so quickly. So glad to be here, and I've been traveling around the state and really familiar with the diseases that we deal with in our major crops. But for this talk today, we'll look at some of the early diseases in wheat and some of the decisions we can make to manage these diseases. And I'll focus mainly on the fungal diseases, and then my colleague Connie, who is the field specialist out of Sioux Falls Regional Extension Center, will talk more on the virus side for the viral diseases in wheat. So again, just a reminder that anytime you can ask a question, you can type in the question either in the Q&A portion or in the chat. And so let us know if you have any questions. We'll answer those as we go along. And then also at the end of the hour, we'll have extended discussions. So when it comes to early diseases and making those management decisions, of course, the first thing is going to be, what are those diseases we see in wheat that we should be thinking about? And the first one and the most common one is going to be tan spot. So tan spot can be found pretty much on any field. Of course, the level is going to vary depending on a number of risk factors. This is a residue-borne disease, so you're going to find it especially where you have wheat on wheat or where the rotations with other crops are shorter. So for example, if you have just 1 year out of wheat, if you plant wheat, you might still get tan spot. The other thing we need to know about tan spot is that this disease has quite a range of temperature for which it can infect wheat. So that's where you'll find it pretty much anytime you are in the field scouting. So even as early as a green up or tearing, you can find tan spot. For winter wheat, in the fall, you can also find tan spot infecting wheat. So it's a pathogen that really has a wide range of temperature for which it can infect wheat. And we shall see with other diseases, you need specific temperature range for these diseases to develop. And if you have transport coming early, so for winter wheat, if you have some infection starting in the fall, that means you have really a high inoculum that will build up into spring. And so under those conditions, you can have transport take out some yield. But for the most part, it tends to remain on the lower leaves, and so may not cause significant yield loss as some of the other diseases that we shall see. So here's an example of the life cycle of this disease. It survives on wheat stubble. You can see these little black dots. Those are the ones that in the spring will absorb moisture, and then they will swell. And once they swell, they will spew out these spores that are called ascospores. And these are the ones that will cause the initial disease on the leaves. However, once the disease has established, the pathogen will produce the second type of spores called conidia. And these tend to be really many, and these tend to be more light, so they can be blown by wind, and then they will cause secondary infections. So if you have the conditions right, then you have these multiple cycles happening, and that's where you have really high disease buildup on the crop. And as I mentioned, if you have wheat on wheat, where you have a lot of this stubble where the pathogen will survive, then you can have this disease develop quite early and will cause issues. For example, here we see these plants that were infected, the disease is moving to the mid canopy. And also we see very few tillers on these plants, and that could be attributed to a lot of transport that develops early in the crop. Another disease that we can see develop early in wheat is powdery mildew. So powdery mildew is pretty easy to diagnose because you can see how the symptoms look like ash that was misted on the plants, but actually this ash-like spores, they cut off the light, so light interception becomes poor, and these leaves will not photosynthesize as they should. And if you have a lot of this disease also developing early, you can also have abortion of the tillers that will not, develop to become normal tillers. This disease, powdery mildew, requires more of the humid conditions and also kind of moderate temperatures, so not too hot and not too cold. That's where you find this disease developing. It's going to be favored by over-tillering, so high fertility environments, or where there was overplanting. You can have issues of powdery mildew developing in your crop. The pathogen itself will also survive on residues. So, where we have shorter rotations or wheat on wheat, we can have powdery mildew also develop. I should mention that I've also seen powdery mildew develop in fields that had been planted into alfalfa, and then after alfalfa is taken out, then when wheat is planted, because of that high nitrogen and over-tillering, you tend to have powdery mildew develop in those conditions. So here I'm showing the progression of powdery mildew, as I mentioned. So you can see in this picture on the left, a lot of tillers, a lot of foliage. And when you have powdery mildew come through, you're gonna see these premature death of these leaves because of powdery mildew. First of all, there's poor light penetration into the lower canopy because of over-tillering. And so with the addition of powdery mildew, then you have these leaves that are really yellowing and dying prematurely because of powdery mildew. Even on the upper leaves, this powdery mildew can develop also on the upper leaves, and of course, will reduce the yield potential of the crop. The last disease that I will talk about in terms of the early diseases that can develop in wheat is stripe rust. And as most of you know, stripe rust can be a hit and a miss. So depending on if we get inoculum coming from the south. So this is one disease that the pathogen may not survive in South Dakota, especially where we have the normal winter conditions we expect in South Dakota. But we have had 1 or 2 years in the past where winter conditions were very mild. And so if we have the rust start infection in the fall, it can survive in South Dakota under those conditions where the winter temperatures are mild. And so if you get this infection in the fall on winter wheat, and then we have good snow cover, then you might have a few instances where striped rust will survive in South Dakota. But other than that, the inoculum would be blown from the south, and this rust, striped rust, requires cooler temperatures. So anything less than 65 degrees Fahrenheit will favor striped rust to develop. As we warm up later in the spring, then striped rust won't survive and won't cause significant disease, especially where we have night temperatures warmer. Then striped rust usually is not a problem. But in some years, we have seen striped rust really take off and become a problem, as you can see here in these pictures. It's one disease that can really develop so quickly. So if you're not scouting, if you're not, kind of up to date with the diseases being reported in wheat, yeah, then the next day you go to your field that was looking fine might be looking like this. So this is one disease that we need to kind of keep a watch, especially if we hear reports that striped rust is developing in Nebraska and other neighboring states. Then we know that we have inoculum and we need to be scouting our fields. So these are the three diseases we usually see early in the season. So tan spot, powdery mildew, striped rust. We do have other diseases, of course, that develop in wheat, but these tend to be a bit later in the season, as we shall see. So this is one disease that would develop later in the season. So this disease is called stagnospora blotch. So quite different from tan spot. It's going to form this lens-like lesion that develops usually on the upper leaves, and that's because it requires warmer temperatures, so temperatures above 70 degrees, and that's why we tend to see it later in the season, and that's why we see it also on the upper leaves because of the conditions that favor this disease to develop. So knowing what diseases are going to develop and knowing the conditions that favor those diseases can help us as we think of management practices, what would best be a strategy to control these diseases. We have other diseases that can affect wheat like leaf rust, but leaf rust also comes later in the season. Stem rust is not as common because of good resistance that we have in our varieties. And these diseases, I am not focusing so much on them for this talk because fungicides that we use to manage other diseases like Fusarium head blight will take care of the diseases that develop later in the season, like stagnospora, like leaf rust. So really the question is, for these early diseases, what should be the strategy? What should we be looking at in order to control them? And so I have here a few reminders that we should be doing if we think of managing these early diseases and also in general diseases that develop in wheat. So we want to start with a clean field. We want to start with a seed bed where we don't have disease pressure. So definitely where possible to rotate, and perhaps more than 3 years out of a crop would be appropriate, would be optimum to try and reduce the disease pressure. So of course, having a 3 crop cycle or even more 4 crop cycle would be great, but sometimes the economics and the agronomics on the field may not favor that. But at least try to space out wheat so that we're not having accumulation of inoculum, especially tan spot, those diseases that are going to survive on residue. So tan spot, powdery mildew, stagnospora, other than rust, pretty much all these other diseases are going to survive on the residue. We want to select a good cultivar that is resistant or tolerant. So resistance is not very common for a number of diseases, but we do have resistance, especially for rust diseases. For Fusarium head blight, we have tolerance and a moderate resistance. So I'm actually looking for a variety that is going to be good against some of the challenges you have. For example, if you're planting wheat on wheat where disease pressure is likely to be high, then you want to take the time and look for the variety that has better rating for these diseases, especially Fusarium head blight where we have resistance in the available commercial varieties. I did mention something about planting population. Of course, this is going to vary depending on the farm, depending on the time of planting, depending on the class of wheat. But you want to make sure that you're not overplanting. And if you're planting slightly on a higher population, then you may want to watch your fertilizer levels, because if you're overplanting and then also over fertilizing, then you're going to have these tillers that come up that, won't encourage good air movement, especially in the lower canopy. And if you have a disease like powdery mildew or tan spot, it can really take off and cause early disease problems and yield loss. Yeah, so I did mention something about fertilizer, and tomorrow we'll have a talk on fertilizer management in wheat. So more will be talked about that. But in winter wheat, especially if you're able to split nitrogen, so that way you're not encouraging over fertilizing early in the fall time, then that may reduce or may regulate the tearing of winter wheat and also help with disease pressure. So the big question, of course, is how about a fungicide? Can I apply a fungicide early in the season to help with that disease pressure? So I'd like to pause here, and I don't think I give an alert to Matt type this in the poll, but in the chat, if you're able, you can type and let us know what is the main concern when it comes to applying fungicides in wheat. Is it early foliar diseases like tan spot or stripe rust, or is it more on the fusarium head blight side? So I'd like to gauge what you feel about fungicide use in wheat, whether you primarily apply fungicides in wheat for controlling early foliar diseases, so like tan spot or stripe rust, or it's more on the later time in the season where you're applying a fungicide to control fusarium head blight. So if you can type in the chat, that would be great, just to kind of share to see where the main concern is. Okay, so I'm seeing a few responses here on B, and one person has A for leaf diseases. It looks like a few do agree that perhaps a fungicide is applied later in the season for the control of fusarium head blight and other foliar diseases that are developing at that time. So that's really also the findings from research, that an early fungicide may not necessarily be profitable, especially in times where we will need to apply fungicide for scab. So having two fungicides in one season, does cut on the profit in wheat. So are there times, or can we be strategic and apply one fungicide and control all these diseases without necessarily having a yield loss? So when we're thinking of an early fungicide, some of the people we've talked to, they say, a strobe early in the season is cheap, so why not use it and protect the wheat? Of course, it's going to help with the protection of against those diseases like powdery mildew, like tan spot. But the question is that this fungicide we put on early in the wheat won't necessarily protect the leaves that develop a little bit later. So flag leaf and the leaf blow flag leaf, and as well as protecting it against fusarium head blight. So which means where in seasons where FHB is going to be a concern, we have to come back with another fungicide. And as I said, that tends to reduce the price, the profit. So what are some of the things where we can balance our fungicide application so we optimize its efficacy? So I'm going to look here at some of the data that some of the experiments we've done in the field to show that early fungicide versus late fungicide and how that can be a bit more profitable. So looking at here, some of the work we've done, looking at an early fungicide at tearing, and then applying a fungicide at tearing and followed by Prosaro at flowering, or just comparing Prosaro by itself at flowering with untreated chicks. So this is looking at two varieties in winter wheat, Expedition and Sour Wolf. And as we can see, especially where we have a susceptible variety, that early fungicide won't give us a lot of protection on the flag leaf. Of course, flag leaf it develops much later after the initial application of the fungicide. And so that's why we may need to come back and apply another fungicide to protect our flag leaf from diseases. So the early fungicide, of course, is going to help us reduce that disease on the leaves, but it won't protect the upper leaves. And also, again, if we have FHB, definitely we would need another fungicide for FHB. So another fungicide, whereas it may reduce some disease, but on the flag leaf, when you come later to assess, you are almost seeing the same level of disease on the flag leaf where you have a fungicide and where you didn't have a fungicide on a susceptible variety. When it comes to yield, and of course that's the bottom line, you know, how is that at a fungicide contributing to yield increase? So an early fungicide by itself, just because, you know, we're applying that fungicide early and the upper leaves are not protected, the fungicide alone, when applied early, may not contribute significantly to yield increase, as we can see from this graph. But if it's applied at cherrying and then followed by a fungicide at flowering for scab management, those programs tend to be more profitable. So the yield increase is really significant. Compared even to Prosaro by itself, if applied at flowering, you can see that the yield difference where you put a fungicide followed by another fungicide at flowering is doing about the same by just having Prosaro alone. So this is where we say, and I will give exceptions, you know, where we have other diseases, perhaps there we may need a fungicide. But if you come and scout and you're not seeing a lot of disease at clearing, even when the fungicide is cheap, even when you're gonna mix it with a herbicide at that time, you may save that money and just put a fungicide at flowering and you won't lose yield loss. So here's looking at programs where we've only applied fungicide at heading or followed it with fungicide at flowering or just looking at flowering alone. So you can see that these programs are all going to control the disease pretty well compared to non-treated. But again, the idea of just putting one fungicide could be significant without necessarily putting an early fungicide. So here we're looking at a new, relatively new fungicide, Miravis S. And one advantage of Miravis S is that it can be applied at heading and really help us to control Fusarium head blight. So there has been a question, you know, what's that window where I can apply a fungicide? And we've been saying flowering is the best window. But now with Miravis S, you can come in a little early and still have good control of the disease, although still, as we shall see, especially when it comes to dawn, flowering becomes the best timing, even for a new fungicide like Miravis S. So he's looking at yield for two varieties, Samson and Boost in spring wheat, and again, looking at those different timings. So the best timing is going to be flowering for maize. You can see that yield is pretty good. And as I mentioned, when we don't have dawn data yet for last year, but even when it comes to dawn management, Miravis S at heading does have a reduced dawn level, but not as significant as the flowering timing. So again, Miravis S best timing would be flowering, but if you put it at heading, you'll still get good yield and control of reduction of dawn. So a takeaway home message really for managing foliar diseases using fungicides is that if you can come in early, do with a fungicide, do that only if you're seeing significant diseases, especially looking at diseases like stripe rust, tan spot, especially where we have an extended warm conditions that may encourage disease development early in the season. For winter wheat, then there you may want to consider applying a fungicide. Of course, where you have wheat on wheat and you're coming in at the time of herbicide timing and you're finding a lot of disease as seen in this picture, then an early fungicide there is justified. But for the most part, if there's very little disease developing early in the season, we can wait and apply one fungicide at flowering, take care of, protect the flag leaf, control Fusarium head blight, and minimize yield loss. So those are the conditions where we may consider an early fungicide. Also, if we have stripe rust developing early, there we may need a fungicide as well. So here we have some tools that can help us kind of follow disease development in the season. If you're wondering, have we been seeing the weather conditions that favor disease development? These are the tools we can use. to control, to monitor disease development. Matt, if you can, you could type this in the chat so people have the links. And then you can subscribe to some of these tools. The SCAB initiative has the Fusarium herbicide prediction tool that we can use to track areas where the risk is high. For rusts, we have the rust tracking system where you can go in and look at areas that have the striped rust. That can give you an idea how to plan, especially a fungicide for our wheat crop. So because of time, I'm gonna stop here and give some minutes for Connie to talk a little bit on virus management decisions we can make managing with viruses.
Well, good morning. I'm just going to briefly go over a couple of wheat viruses that we typically get questions on and see within the state here. The first disease or first virus that we'll talk about is wheat streak mosaic virus. It can cause field-wide infections leading to very heavy yield loss. When we talk about wheat streak mosaic virus, it's not something that just happens on its own. It needs a vector to transmit that virus, and that vector would be the wheat curl mite, so that transmits the wheat streak mosaic virus within the plants and throughout the field. These wheat curl mites are blown in by the wind from one field to another to nearby fields, really causing that infection. As they feed on the plant, they will spread that virus throughout the plant. So the wheat curl mites, real briefly, they crawl inside the leaf whorl near that growing plant. Those non-adults, they acquire the virus. The bugger with the wheat curl mite is, once they're inside that whorl, there's really no insecticide that you can apply. It's hard to get it down in there. These wheat curl mites, they can survive as adults, nymphs, or eggs. The most damage is that indirect through that wheat streak mosaic virus transmission. So the wheat curl mites is one thing, but when they are able to chew and feed, they are able to transmit that virus from plant to plant. So we know that wheat curl mite, they're blowing in with the winds, they kind of drop down on the plants, and that's how they're able to move throughout that field from the previously infected neighboring field. And again, the other part is with wheat streak mosaic virus, there's many different weeds that the wheat curl mites find themselves on. So the unfortunate thing is they will blow from those volunteer wheat or grassy weeds onto our winter wheat or spring wheat. So that's how it can move there. Anyhow, the virus, what it looks like is kind of like the top picture here. It's very pale. You can have some mosaic of color of a dark green, light green, almost a yellow with stripe with a pattern, and then stunting. So you can have the very short stunted plants, or you can have the prostrate where it kind of grows and spreads versus kind of coming up within the plants. With the wheat streak mosaic virus, again, unlike most of our diseases that are just kind of spotty or irregular throughout the field, wheat streak can take out the entire field, as you would see in this example here, where it looks almost yellow, infected with wheat streak mosaic virus. Anyhow, wheat streak is usually more of a problem in winter wheat and less of a problem in spring wheat. And that's mainly due to the amount of growing time and some of the temperatures and things that we've seen. So what is the impact of WSMV or wheat streak? Well, it really depends on the cultivar planted, the time of infection, weather conditions, and whether or not there's other viruses there. Yield loss can be from very minimal to almost up to 100% yield loss. So it's not a virus that we want to take for granted. We really want to get out there and scout. Unfortunately, there's nothing that you can do if you find wheat streak this year or out in the field right away, you'd want to make plans for the next growing season. Some of the risk factors for wheat streak is if you have that pre-harvest hail, have a lot of shattering, a lot of dropping of those wheat kernels down to the ground would cause some of the volunteer wheat. Hence, we know with wheat curl mites, they like volunteer wheat and those grassy weeds. So we are able to just transmit and keep those wheat curl mites going. Warmer temperatures into the fall, so like warmer Octobers and Novembers, open without much, snow cover, anything like that, causes a happy home for the wheat curl mites. The virus, it needs that living host. So as long as the plant's growing, is able to continue replicating within. Also, if we plant early, so really encouraging like a later planting, but the early planting wheat, whether it's in wheat stubble or fallow, with the volunteer wheat causes more issues for wheat streak. And again, planting next to a previously infected wheat field will cause some issues there. So some of our management things that we recommend is to destroy our volunteer wheat and our grassy weeds. So we call it like breaking down that green bridge at least 2 weeks before planting. No, I'm not saying you have to do tillage. You need to put on a chemical control to burn down those weeds and volunteer wheat to break that bridge of the wheat curl mite so it's not able to continue on. You want to delay your planting so the later you can plant in the fall, that shortens that growth window that the wheat curl mites can blow in and start causing any infection if they feed on that virus plant. Wanting to look at tolerant cultivars, and then rotating to broadleaf crops will also help to reduce some of that wheat streak pressure out in the field. The other disease real briefly here that we see in South Dakota is barley yellow dwarf. As you notice in the picture here, it's got some yellow on those kind of upper leaves. Either one of the viruses can be throughout the plant. Typically, we'll see barley yellow dwarf on the upper 2 leaves of the plant. Usually wheat streak we'll see on the bottom 2 leaves of the plant as kind of a quick diagnostic. I mean, again, to know for sure which virus you have, recommend pulling samples and sending in for testing. How is barley yellow dwarf spread? Well, this one is spread by aphids. There's 20 different aphid species. The 3 that would transmit barley yellow dwarf are the bird cherry oat aphid. That's the most common one found and observed in South Dakota here. And then the English grain aphid and the green bug. These aphids acquire barley yellow dwarf while feeding on the infected plants, and then they continue to transmit it during subsequent feedings. Real briefly, the barley yellow dwarf symptoms are often confused with wheat streak mosaic virus, nutrient deficiency, root rot diseases, and environmental stress, which is a lot of times most of the issues that we have with disease anyways, that they're look-alike things. But with barley yellow dwarf, it will be found in a few plants or a few small patches. It's not uniform like wheat streak can be throughout the plant. Again, you'll see some yellowing in the early phases of barley yellow dwarf. And then depending on your cultivar and how things change, you may see like a reddish purple color on that upper flag leaf. So you might see that reddish purple discoloration. That's pretty characteristic of barley yellow dwarf. Real briefly, some management, again, delaying the planting dates. Again, it just allows less opportunity for the aphids to come and to start transmitting that virus. Wanting to look at tolerant cultivars, there's not a lot of resistance out there. It's more of a susceptibility that some are more susceptible to barley yellow dwarf than others. Again, cultural management, controlling those weeds and volunteer wheat, and then may look at an insecticide, whether it's a seed treatment or a foliar applied one in the fall. But with that, I'll just pop my information here and encourage you to stick around at the end of the session for more questions and conversation.
As this is going on, there were a few questions in the chat, but because of time, we'll answer these at the end of the hour. So as Connie said, please stay on and we'll have all these questions answered. Also at this time, Matt, could you bring up the poll to ask the participants to help us answer these 2 questions so we can know better how to serve you next time. Hopefully, Adam, you've been able to rectify the technological challenge. So I will be handing over to you here shortly so you can talk to us about insect management. So thanks, Connie, for the presentation on virus management. Again, any questions you may have, because of time, we want to give Adam more, some time to talk on insect management. We'll answer these questions at the end of the hour. Okay, so Adam, I think I'd already introduced you, so please go ahead and start your presentation.
All right, thank you. And see here, there we go. Hopefully it's working now. I was having a little bit of a technological difficulty there, but things look better now. So as Emmanuel said, I'll be talking about wheat insect pests and their relatives, as you can see, and we'll get to that. But Connie covered some of those, and I'll add maybe one more relative of insects that can be a problem. So this is from a question from a couple weeks ago. Somebody asked about weevils that are on wheat at harvest and what to do about them, because they seem to also show up in the grain bin. Well, I did a little bit of research, and it looks like there's two species that can be the culprit of this. The first is the rice weevil, and the second is the maize weevil. And so both of these can be on wheat at harvest and then be carried into the grain bin. Now, a refresher, the rice weevil is small. It has a shorter snout on the front of its head here. The adults and the larvae can feed on the seeds. The big catch here is rice weevils are not strong flyers, and so they generally don't travel long distances. A lot of times they show up at an area where there was already an infestation. So they probably aren't the most common species out in the middle of a field. Their life cycle generally requires high moisture content, somewhere around 70% humidity, and that's our signal that you have a humid environment because you have an infestation. And then we have the maize weevil. These also are small. They have a shorter snout. The adults and larvae feed. The big difference here is that these are strong flyers. So for weevil management, there aren't a ton of different things that can be done. The first is to run that fresh harvested wheat through a grain cleaner to try to knock out some of those beetles. The second is to do your pre-bin treatment before you bring the grain in. Most commonly used is malathion for that. You treat the sides of the bin. That's after you've cleaned the bin. And then there's also the recommendation of using a protectant insecticide, which would be applied at the auger as you're preparing the grain and sending it into the bin. So that's all I could find to answer that earlier question on weevils that are out in the field. One of the things that you can do is harvest a little bit earlier. I don't have it on that slide, but that can also reduce the number of weevils that are infesting that grain. So now we're going to move into early season pests. So we went from late season and storage pests of wheat to now early season pests. And probably the two most notable species of our early season pests are cutworms. And it's the army cutworm and pale western cutworm. Now, both of these species are more of an issue as we go to central and western South Dakota. The army cutworms have an interesting life cycle, which we'll talk about, but they're probably, if they're out in the field, they're there right now. They're probably not doing a lot of feeding since it's a little bit on the cold side for them. The pale western cutworms would be eggs right now. So the army cutworms can vary in color a little bit. If you remember last year, if you were in the Pierre or western areas of the state, so Pierre West, there were a lot of moths that showed up, and people were saying they were showing up in mailboxes and everywhere. And it turned out those were army cutworm moths. And so army cutworms actually feed in the spring, pupate, and then the moths take off shortly after that. The moths actually go to the Rocky Mountains to hang out there in the summer They kind of do a summer hibernation. And it's actually a food source for bears. And so then in the fall, they come back from the Rocky Mountains and lay the eggs in green fields. And so those eggs hatch. Typically, the moths target anything that's green in the fall. So a lot of times that's our freshly emerged winter wheat or alfalfa fields. Caterpillars feed a little and then they'll overwinter. There have been cases where this fall feeding, when the weather conditions are just right, we can see a lot of defoliation occurring even in the fall. Then they'll overwinter in the soil and they start feeding again in the early spring. They can cause a lot of stand loss. First of all, defoliation if there's large populations. However, if there's enough of a population, they can cause some stand losses. Mild or moderate feeding from the army cutworm doesn't necessarily have to be treated because the plants can rebound from that. They'll be able to recover. And that differs quite a bit from the pale western cutworm. Now you can see the differences are pretty obvious in coloration. These get their name because they're light in color, no pattern really, just kind of a light colored caterpillar. As I mentioned, these overwinter as eggs in the soil, and then they hatch in the spring. Now the caterpillars feed underground, so that's one of the big differences. The army cutworms feed above ground on the foliage. Pale western cutworms feed underground, and this actually causes them to be more of an issue because when they feed on plants, they actually kill them. And so they can have huge impacts on plant stands and really reduce the stands if there's a large population present in the field. These do show up a little bit later in the spring, and so typically they aren't as much of a winter wheat pest as they are a spring wheat pest, but it's something to also monitor for when scouting. So anytime we start seeing dead or dying plants in the field, it's important to figure out what's causing those. So for these cutworms, the thresholds for the army cutworm are 2 to 4 caterpillars per square foot. And then the pale western cutworms are 1 to 2 caterpillars per square foot. The reason that's lower is because they do cause more of an issue for the plants since they're killing them as they feed. For both of these during the day, you'll need to dig into the soil around damaged or dying plants with a trowel and figure out if the populations are present. Pyrethroid insecticides are recommended for management. They need to be applied in the evening. It's a little bit tougher with the pale western cutworm just because it is underground. So it's a little bit harder to get good management of that pest. So now we'll move on to bird cherry oat aphids. As Connie mentioned, aphids can be an issue in our wheat. Bird cherry oat aphids are the most common. These are dark olive green and they're really easy to tell apart from everything else because they have this burnt orange or red patch down at the end of their body. These migrate to wheat in late spring, early summer. They'll feed a little bit. The populations can take off. There is the possibility for them to reduce yield just through direct feeding with large populations. However, the real culprit of a problem here is that they can vector barley yellow dwarf virus. Now, the spring summer infestations aren't a huge threat for barley yellow dwarf virus. What happens is these are harbored after wheat harvest. They go to other crops like corn, other small grains. They'll build their populations up, and then they show up again in the fall. And that's when we have to really worry about the transmission of barley yellow dwarf virus to the winter wheat. And so the thresholds, I don't have them up here, aren't extremely high, but a lot of times we wouldn't even notice an infestation. But that's where we worry about is actually those fall infestations. That's when they really need to be scouted for. Another aphid we watch for is the English grain aphid. Now these are yellow-green. They're fairly large aphid, easier to tell apart from the other ones. They don't have that orange patch, but if you look, these tailpipes or cornicles are black, and then they have black markings on the legs. It's a little bit harder to see on the antenna, but they have dark banding on the antenna. So green aphid with black pattern on the legs, black tailpipes, probably an English grain aphid. Now, the bird cherry oat aphid will be on just about any part of the plant. English grain aphids prefer to colonize developing heads. They will feed on the leaves, but they tend to migrate towards the heads as those are developing. Again, these can vector barley yellow dwarf virus, but if we get large populations, they can also reduce the yield through direct feeding. Whoops, I went the wrong way. There we go, green bug. So our next aphid species is green bug. These again can vector barley yellow dwarf virus, reduce yield through direct feeding, but a difference with these from everything else, they get their name because they're kind of a yellow-green, but they can cause discoloration when they feed. So the leaves will get a discolored, turn brown, and that's due to the saliva that they have. With green bugs, we typically don't see a lot of infestation of these throughout the year in South Dakota. We do see more of the bird cherry oat as well as the English grain aphid. To scout for aphids, we recommend walking in a zigzag pattern and examining plants. That's the best way to cover a large portion of the field and get an idea of what everything looks like. For management, these are another thing you want to try to prevent that green bridge. One of the ways to do that is delay planting a little bit in the fall. Seed treatments in the fall can be effective at reducing some of these aphid populations and deterring them from infesting the wheat. And then if the populations are present, foliar insecticides can also be effective for reducing those populations. The issue with the foliar insecticides is that there's already a likelihood that the barley yellow dwarf virus would have been transmitted to those plants. So you'd be killing the aphids, but the virus might already be present. Next, we're going to talk about true armyworms. I started in 2015 at South Dakota State University. And during my interview, I was asked if I had recommendations for managing true armyworms in wheat. So I was interviewing in late July, and this pest came up during my interview because people were having issues with it. This pest has been an issue almost every single year since I've started. Typically, we'd say true armyworm infestations in wheat in South Dakota would be sporadic. However, more times than not, it's shown up. A lot of times it shows up and it's not caught right away, so the infestation is able to be present for a week or two. As a result, there can be a lot of defoliation, and in some cases, large areas of the field are just destroyed by this insect's feeding. It's the larvae that we worry about with the true armyworm. These guys get their name armyworm because they can show up in very large populations, and then they move through a field like you would expect an army. They move as a group in the same direction, and when you see that, it kind of looks like they're mowing down the field. Now, these do migrate from the southern United States, so there's always a chance that we won't see a population of them in South Dakota if weather conditions aren't extremely favorable. It also makes it a little bit trickier to determine exactly when they're going to be showing up in the state. However, like I said, they've been a pretty much an annual pest for the last going on 6 years now. They have 3 pairs of true legs for identification, and then they have these 4 pairs of pro legs. Now, I like this picture because it shows you this black banding. So that's distinctive of the true armyworm. The pro legs will have that black banding. They will also have an orange stripe on each side of their body. Now, the coloration of these can vary a little bit. So they can be dark, almost a black color. They can be a green color, as shown in this picture. And from the same field, they can also be almost a tan. So they can vary quite a bit in color. Another very distinguishing characteristic is the head. It's going to look like somebody took a pen and scribbled on their head. So they have a network of dark lines present. And so that can be used to identify them. As you can see in these pictures, a single caterpillar can do quite a bit of feeding injury. Shown here, they just kind of start on a leaf and they keep feeding until it's gone. So they can cause defoliation. A lot of times we'll see yield loss if they feed on the flag leaf. Another major issue though is that in South Dakota, these can show up a little bit later, closer to harvest. And as the wheat matures, as you can see in this picture, sometimes they go for the head. And as there's reduced nutrients, they may clip those heads. So that's where we see a lot of yield loss occur. For true armyworms, we scout using visual counts or sweep nets. The threshold is 2 caterpillars per square yard if you're doing the visual counts, or 40 caterpillars per 30 pendulum swings. Now for management, a lot of times since these are showing up really close to harvest, we're trying to avoid insecticides with long pre-harvest intervals, that time between application and when you can harvest that crop. The insecticide Bolton has a 7-day pre-harvest interval. The insecticides Coragen or Prevothin, they have the same active ingredient, have a 1-day pre-harvest interval. So if this pest is showing up close to harvest and it's starting to clip heads, I would recommend either Bolton, or if you're really close to harvest, Coragen and Prevothin. The thing is though, you want to try to reduce that population before it causes a lot of clipped heads or just yield loss in general. Now along the same lines, another group of pests that we have that can show up and cause defoliation or clip heads are grasshoppers. We have 3 main species in South Dakota that I watch for. Now I don't have the one pictured here, it's the 2-striped grasshopper. It's a fairly large grasshopper and it has 2 light colored lines that go down its body. The other two species are the differential grasshopper, which is shown here. They're those big green grasshoppers that have the dark markings, the chevrons on their hind leg. And then the red-legged grasshopper, which is shown here. Now these are a smaller species and they get their name because typically that back leg has a segment that's really noticeably red compared to the rest of the body. Now these show up typically towards harvest, or they can also be an issue for emerging winter wheat as that winter wheat's coming up and everything else is starting to dry down in the area. Most of the time, these are more of an issue around the edges of the field because they're in the road ditches or anything else that was green. But once they start noticing something that's more succulent, they'll move to that. The threshold for grasshoppers in wheat is 11 to 20 grasshoppers per square yard. We'd recommend using foliar insecticides to knock the populations down. However, there's some evidence that insecticide seed treatments for winter wheat can deter feeding and allow the wheat to get to a point where the grasshoppers won't cause as much of an issue for it. There's also some evidence that doing a higher seeding density right around the edges of the field can help because the grasshoppers will move in, they'll feed on some of it, but they most of the time won't remove all of that wheat. So planting at a higher density can account for some of that stand loss that you might see on the edge. I have a note here to watch closely for grasshoppers in 2021. And the reason for that is in the central part of the state in 2020, we saw some huge outbreaks of grasshoppers. They were all the 2-striped grasshopper. I lost some research plots that were sunflower. 1 week they were there and the next week they were gone. So something to really watch for. We had ideal conditions for the grasshoppers into the fall as far as egg laying. It was also drier this fall. The way things are looking, we could be going into a drier spring. A lot of the state is in drought conditions. So as we start thinking about our spring conditions for grasshoppers, as well as what we might be looking at for next fall, it's kind of hard to say for next fall, but there is a chance that we could be going into a year with some grasshopper outbreaks. So central part of the state is where I'll be focusing a lot of my attention just because we already had issues last year. But there is a chance that these grasshopper populations could have outbreaks in more areas than even there. So something to really monitor for as we go into the season. I won't go into the wheat curl mite too much since Connie and Emmanuel covered some of this pest. They are very small, so you'll need a hand lens to see them. When you have the hand lens, they're kind of cigar shaped. So they're small, they're white, they tend to be in the midribs of the leaves. The adults are carried on the wind, so these do not have wings. And so they're very small, they get taken up on the wind and then moved into new fields. They overwinter on the green plant material, and one of the ways to manage them is sometimes delaying planting can be effective. Biggest thing is to avoid the green bridge. And then one of the other non-insects that we had in 2020, it was kind of an unusual thing for us to see, were slugs. Now, typically slugs aren't an issue in South Dakota, except during times when we have cool, wet conditions, and especially in fields with high crop residues. So those no-till fields can be a target for some of these non-insect pests that enjoy those cool, wet conditions. So you can see here, this is from South Dakota. This field had a lot of residue, and there's our slug friend right there. And as you can see, he's actually feeding on the green material. So they scrape the foliage or the stems. And when they do that, they'll kind of leave cutouts, or as you can see here, the plants start to break, and they also sometimes start to deteriorate due to that feeding. Other cases, the slugs can show up earlier in the season. So in South Dakota, these were a pretty late season issue in 2020. Other places where they see slug issues in wheat, it's because they're showing up early in the season and feeding on germinating seeds. And so they can completely destroy the seed once it's swollen and starting to germinate. There are a lot of evidence that insecticide seed treatments can reduce the populations and that slug feeding. We still don't have a great management recommendation if you have slugs show up later like we did in 2020. I went through the literature, and from other states, the recommendation is to apply urea. However, in talking with Anthony Bly, there's a chance that that could cause as many issues as the slugs are causing. So I guess with the slugs, one of the things we'll have to do is just wait, and hopefully the weather warms up and dries out a little bit so that they aren't as much of an issue. Now, looking at the forecast, there might be areas where we still have the conditions that fit for these to have an issue, but it looks like we're going to be a little dry this spring to really have a lot of slug problems. So I'd like to thank you for your time today and for attending this crop hour session. I believe there will be a short poll here starting up. If you have any questions that you'd like to ask me, please feel free to send them to my email, which is shown here on this slide. And otherwise, thank you, Emmanuel and Ruth, and be happy to answer any questions as they come up.
Thanks, Adam. So at this point, we can have questions on the insect presentation, insect management presentation, but we also have a session after the hour to answer any other follow-up questions. So as the poll is going, I'm also gonna upload the QR code for the insecticide presentation or insect management presentation. So so also be watchful for the email in your mailbox that will ask you for a short survey. So again, this is to help us to know how best to improve and deliver better information on agronomics of our crops. So this will be coming on Friday at the end of the week. So thanks again, everybody, for joining us today. We'll continue the discussion. Everybody will have an opportunity either to type in or unmute and speak out their questions. So we have a lot of time, and there are a few questions that came in the chat. I haven't seen the ones specifically for insects, but we do have a few on diseases. So if I can start answering some of those questions. So there was a question on, let's see here. One of the questions was what the letters meant on the bar graphs that I presented. So the letters were showing significance. So if it was for disease severity or for yield, if a bar has letter A and the other one has letter B, it means they are significantly different. They are statistically different based on probability value of 5%. So that's what those letters meant. And for the most part, we saw that an early fungicide did not have disease severity different from the non-treated, just because when we evaluated the flag leaf at that time, the earlier fungicide that was applied did not provide any protection on the flag leaf. So that's what that meant. Also, when it came to yield, we saw that an early fungicide did not contribute to yield as much as the fungicide applied at flowering. And so those were the differences that I was showing in those graphs. So somebody had a question there. And then there was also a question on bacterial leaf streak management. What are there anything management practices that a grower can do? So for bacterial leaf streak, being a bacterial disease, we can't apply a fungicide. And the bactericides that are on the market are pretty expensive and are not as effective for some that we've looked at in our trials. But we have some varieties that are pretty good against bacterial leaf streak, especially in spring wheat. Also in winter wheat, some of the recently released varieties tend to be a little bit tolerant to bacterial leaf streak. The bacteria will be on the residue, so rotations will help. Although BLS can also come from seed, that tends not to be a big issue, like where we have inoculum coming from the field. So unfortunately, because it's a bacterial disease, there isn't much we can apply in season, but selecting a variety may help with a bacterial leaf streak management. And so I'm sure there will be other questions. And so to make sure we provide everybody an opportunity, everyone is going to be now transitioned to the panelists so that we can all have the opportunity to either unmute or type in a question. So now the normal presentations are over. So we're going to transition to the discussion forum.